Most people know me here because I do attend church here. But for those who might not come to church here and who might be visiting, I'll just tell you a little bit about my background too. So I am a pathologist at the Mayo Clinic, but I've had a long and arduous journey to the Mayo Clinic, as my wife can probably testify, because she was part of that all, and also my kids. But I started my life out as a PhD chemist. I worked for many years for Dow Corning, and then down to Kodak, Eastman Chemical Company in Tennessee. And then for some reason, I talked my wife into letting me go back to school and go to do medicine, and I ended up here at the Mayo Clinic. And so I've been involved in science for a very long time. And like Dr. Frisk, I came to Christ later in life, not until my 20s. And so a lot of what has happened to me is I studied this stuff, and a lot of what I studied in science actually brought me closer to God. So I have a little different goal here today. I'm going to just try to explain to you or show you things that I see every day as a pathologist at the Mayo Clinic doing research. And what I think it should do, and what I hope it does, is to provoke your heart to worship. Because our God, I titled this talk, The Unbound God, because our God is unbound. He is magnificent and marvelous. And that's what I hope to get across to you today. So I started with this verse. Nothing in all creation is hidden from God's sight. Everything is uncovered and laid bare before the eyes of him whom we must give account. God sees everything. That's why I titled this the God who is unbound. He's not bound by the things that we're bound by. And that makes him magnificent and marvelous. So again, my goal here today is to get you to kind of see things that are going on in your body right now on a molecular level. We're going to talk a little bit what happens in the heavens, just to kind of see that end. And then I'm going to take you to the God of the small, the cellular level, the molecular level. And what I hope happens to you is it moves your heart to worship God, because that's really my goal here today. So here's my outline. My outline is actually, back. All right, here, this is my outline. It's too touchy. So this is what I want to do. This is King David, one of my heroes of the Bible. I love King David, right? He was quite a man after God's own heart. But here's my outline of my talk. He said, "Great is the Lord and most worthy of praise. His greatness no one can fathom." The things I show you today, I can't fathom. I can't give you an explanation of everything, but I can see them and I can explain them to you. But I cannot, in my finite mind, fathom everything that's going on. But he says, one generation commends your works to another. That's what I'm here to do today. I'm here to tell you from my perspective to these generations what I see. And they tell of your mighty acts. They speak of your glorious splendor, of your majesty. And I will meditate on your wonderful works. So I hope today, as I talk about this, you really meditate on what's going on and how much God cares for you. All right, so this is where we're going to start. I'm going to paint this. The title of my talk tomorrow is God's Magnificent Cage, and so it's kind of done just to be clever, to get your attention. But I want to start painting this cage right now because I'm going to talk about it for the rest of my sessions here. So I asked the question, what is the most dangerous animal on the planet? So you can think about that. You can find silly things like this little kitty cat. It just shows that even the little kitty cat can look dangerous if you put a rifle in his hand. Or as Carl Kirby showed, you can go on the internet and find this hybrid shark and grizzly bear. Maybe that's the most dangerous animal on the planet if it existed. But sometimes the danger comes in small things, right? This mosquito carries diseases, and it can come and pierce your skin and bite you and give you disease that can take your life and you don't even know it. Maybe that's the most dangerous animal on the planet. But if you're in this car, this elephant looks pretty dangerous, right? So maybe the big thing on the earth, maybe the elephant is the most dangerous animal on the planet. But when we lived in Tennessee, there was a little nature center. And in this nature center, we'd go to it, and I still remember in the back of the nature center, there was this box, and it had like bars on it, and it was all closed in. It said, "Be careful, the most dangerous animal on the planet is on the inside," and you would open it up, and there would be a mirror, right? A mirror. Maybe man's the most dangerous animal on the planet, right? And I think that's sort of true in the fact that we're sinful creatures, and we work on other people, and we have a chance to lead people astray from the knowledge of God. And that's probably the most dangerous thing that can happen to any of us, even more than disease, even more than being torn apart by a wild animal. The fact that someone can lead you away from the knowledge of God is probably the most dangerous weapon that you could have. This is what, I took this from Abigail Adams. So she said this. She said, "I am more and more convinced that man is a dangerous creature, and when mixed with the power, like the grave calls, give, because the grave is never satisfied." The scripture tells us that, right? The grave is never satisfied, and neither is the man who's seeking power, never satisfied. So here's your question. Let's say I forced you to live with this dangerous animal. I said, you have to live with this lion in your house. What would you do? Well, you might decide I would like to buy a cage and keep him. If I have to live with him in my house, I'm going to put a cage around him, right? To keep him from being so dangerous. Or maybe I'll lock him in the kitchen. But I'm going to put some sort of limits on this animal so he can't come and attack me. And in a sense, God, I think, has done that to the human race. Not that he's afraid of us, right? He's not afraid of us. God has no fear of us or anything that we can do, because we can't even begin to touch God in terms of our power. But we're dangerous to each other. And so maybe he's put some limits on us. And that's what I kind of want to look at, is this cage that God may have put us in. And so this is how I'm going to define it. And I'm calling this God's magnificent cage, because I have to remind myself that even I am in this cage, and there's things in this cage that make me unsatisfied. Just like an animal that's caged, sometimes you want out of the cage, right? And so there's things we do to try to escape from the cage we feel like we're in when we feel that cage. I still remember, I have vivid memories of one time going to a zoo, and there was this gorilla in the cage. And for hours and hours, we were just walking around, and he would walk from one end of the cage and just go bang against one wall, walk over to the other side, and he would just slap it with his wrist. And he just kept going back and forth, just slapping the cage on each side. And it made me think, wow, that's exercise in futility. I mean, he wasn't even hitting it hard. He must have been doing this for hours and hours. He knew that cage wasn't going, but yet something in him kept driving to try to, I got to keep testing the walls of this cage. And so when you think about what cage did God put us in, so there's things that we have limits in. One, I'm going to call one time, right? God's put us into sort of a time cage. And we talked about this summer. I talked a little bit about the age of the earth and time. So we're going to explore that dimension of the cage. And he's also put us into dimension, meaning that I live in this 3D space, and I can't go wherever I want to. I'm not omnipresent like God is. The unbound God can walk wherever he wants, but you and I can only go to certain areas. But I want you to think about this, because I put this picture up. I don't know if you've ever seen this movie, but it's the Thor movie, and I want to remind you of a line in that movie. And the line that I want you to think about is when Odin goes into Odin's sleep, right? And it's because, Thor has been cast out of the kingdom. And Loki, the enemy, comes up and he's talking to his mother, and he says, "Oh, what about Thor? What's going to happen to Thor, right?" And what does the mother say? "Your father always has a purpose in his judgment," right? And that's true about our Father, right? Our Father in heaven put us in this cage not because he's afraid of us, not to punish us, but for a very specific purpose. And that's what that's what we're going to talk about mostly tomorrow. But I wanted to define that right out from the beginning. All right, so let's look at these things. Let's talk about the first dimension, right? Time. God has put us into a time cage. We know we're limited in time, and we talk about it all the time. We say things like, "I wish I had more time," right? Time is too short. Oh, how time flies. Where has all the time gone, right? And this summer when we talked about that, we talked about why is it that we care so much about time? Partly because we know it's a limited commodity. And we also know, and we talked about this, well, how do we even define time? Well, we define time based on change, right? If I were to live as a 28-year-old with perfect health the rest of my time, I wouldn't really care what time it was because nothing's changing, right? If nothing's changing, I don't really care what time it is. But because things are changing, then I care. And I don't know if you've ever had this experience. And we know it's a common human thing for time to change and things to change, but yet we kind of look at it and we're kind of puzzled by it. And I think I talked about this. One time I had a friend in college. When I knew him, he was in his 20s, and he was like an athlete. He was kind of a very healthy, good-looking guy, and so I hadn't seen him for 20-some years, I think, and so I ended up in the same town, and I called him up. And I went over to his apartment where he's living. I knocked on the door, and he opened the door. And in those 20 years, he went from an athlete to a guy who was bald with a big pot belly. And I know I couldn't hide my shock. I mean, I don't know what I was expecting, but I knew I couldn't hide because I tried hard not to show any emotion, but I couldn't do it, right? But why should I be so surprised by that? Because time does change things. But it's partly we don't feel comfortable with this time change. That time change is something we're not comfortable with. And after the flood, God limited our time, right? He said this in Genesis 6:3. Then the Lord said, my spirit will not contend with humans forever, for they are mortal. Their days will be 120 years. So time is a one-way arrow. It has a beginning for us, and it has an end. But what is it that we want to do? We want to extend that arrow as far as we can. And some of us dream of going backwards in time, right? Sometimes we dream of that. Our early fathers realized this also, because if you look at the succession from Adam, so Adam, he had Seth, and Seth had a son called Enosh, and you know what Enosh's name meant? It actually means, when you look at it, it means mortal. So by this time, they were starting to realize, something is changing, right? Adam, can you imagine? No one knew the effect of sin like Adam did. He lived in the perfect environment. He walked with God. He saw the effect of his sin, what it did to all of creation. And so by the third generation, they're already naming their kids mortal because they realize, something has changed. But the God that we serve is unbound by time. He says, before the mountains were born or you were brought forth, the whole world, from everlasting to everlasting, you are God. You turn people back to dust, saying, return to dust, you mortals. So we have this desire in us to be like God, right? It's always been our desire to be like God. And so we want to be from everlasting to everlasting. So we go to that cage wall of time and we push on it, saying, and I'm guilty as anything else because my whole research is on trying to find ways to extend everybody's life with certain diseases as far as I can. And so I got to remind myself that I'm not going to win this battle. God put that cage there for some reason. We even say at the Mayo Clinic, even the Mayo brothers died, so your hope of extending your life forever is kind of shot by even that fact. So the unbound God is outside of time. We have no concept of what that would be like. I have no concept of what it's like to see time as one single entity. God can walk forwards and backwards through time. He's unbound by that. Yet, he's done something to us, right? This verse here. He says, he has made everything beautiful in its time. He has also set eternity into the human heart. Yet no one can fathom what God has done from the beginning to the end. So he's done this. In our heart, we realize we want eternity. We're longing for eternity. And if you watch human nature, everyone around you is longing for eternity. And so we are in this cage that God had set up, this time dimension. And like that gorilla, we're walking from one end to the other, pounding on the edges, saying, I want out of this cage. And so you end up saying this in your heart, oh, I want to break free from these shackles, this shackle of time. And you see it in our movies, in our popular culture, right? You recognize these movies. They always love to have this thing about going back in time. We have this movie Back to the Future and the Time Machine and the Terminator, where things come and go from the future, and we create all these kind of funny scenarios. And I kind of think about how merciful it is that we can't go back in time, because if we could go back in time, I don't think we'd get anywhere at all. What I mean by that is that, well, by the time I do bad on a test and want to go back in time to fix that, you will have had some event in your life and want to go back and fix that event. And so we'd all be pushing back, trying to correct everything that we think is an injustice or a wrong. And we wouldn't get anywhere if God allowed us to go back in time. But he does allow us to look back in time, and that becomes sort of our educator of what not to do. I mean, that's what the Old Testament is about, right? These things are written that you can then, for an example of you, so that we don't repeat some of the things that happen in time. So that's what history does for us. And then we dream of the fountain of life, right? We dream of that. And my whole job at the Mayo Clinic doing research is to try to figure out the best way I can to extend your life for as long as I can, right? So we dream of those things. So now I'm going to bring this back into science now. So the physicists are starting to ask interesting questions of time. And one of the questions that the physicists are asking now is the future really limitless? So what do you think about that? Think about that in your heart for a little bit. Is the future really limitless? And one of the examples that I can give you is, because you are sitting here in this auditorium right now, I don't think your future in the next 2 seconds can be sitting in an auditorium in China right now, right? It doesn't seem like that's possible. So is the future really limitless or not? And now even the physicists are starting to ask this. And they're asking this question. It's a very interesting question that they're asking in physics. They're asking the question, is the present determining the future? Or is the future somehow determining what's happening in the present? And I think that's a very interesting question. Now, how in the world could you ever get to this from the sciences? For us, we kind of know that. From a spiritual standpoint, right? I know for a fact that God's going to win in the end this battle between him and Satan, right? There is nothing in this present that I can do to stop that, right? But now even the physicists are starting to look at that. And it comes back to what you were talking about, the quantum mechanics idea. So Albert Einstein was one of the original founders of this quantum physics or quantum mechanics. And he talked about some strange things that happen. So again, we can't go all the way into quantum physics, but basically the idea is that things in life live in certain discrete energy states. They have to jump from one state to another, and there's sometimes no in between. And what that does is create some funny things and when you look at particles in these energy states, it creates what he called spooky interactions that happen over long distances. And what he meant by that was that it seemed like certain things, some certain subatomic particles in one quantum space, once you determine what the one is, it has an effect on something that has another particle that could be a long way away from it that would actually determine what that particle is. I know that's hard to understand, and it's hard for me to grasp. But this was something that came out of his mind, and he was talking about that. And just recently, some physicists did some really interesting studies in the subatomic world where it almost looked, and there's different ways to look at this, that the future event was what was determining the present event. Now, how can that be? The one things that we're looking at is some of the radioactive decay, a subatomic particle. And they said that you couldn't predict the current state until you knew the exact time for that particle when it decayed. All right, so I know that that's really difficult, but they're saying it almost looks like the present knew the future, or the future reached back, what they say, into the present and controlled what was happening. Okay? Very, very, very difficult kind of concept. But I want you to think about that, because now this is part of why I'm thinking of maybe leaving science at this point. Of course, I'm being facetious. Because, if science is really true, right, then why are there so many denominations? We've got now our Armenian physicists who believe that the future's wide open, that there's free will for all these particles, and now we have our Calvinist physicists who are believing the future is determining what's happening in the present. And so now I'm thinking, well, geez, now, boy, science, if it were true, why are there so many different denominations? And, and if it goes on, I've seen this, that the quantum physicists sometimes are trying to shove their doctrine down the people who don't believe in quantum physics. And I think it's going to science may end up being the whole reason why we have wars and, okay. So you can see where I'm going with this. This is what they accuse religion of, right? Religion it just divides people. It divides them into groups and causes all these conflicts. But in science, the same divisions are happening, the same thing. It's human nature that's the problem, right? It's not the religion or the science. It's human nature that we can't sometimes agree. All right. So, but the question is, what does the future look like to a physicist? What does it look like? Here's your hint. This is what, if you ask a physicist, this is what the future looks like. That we're slowly decaying into black dark, that everything's eventually, all light's going to go away, everything's going to go to heat, all the particles are going to go to muons and beyond, and the future's all dark. And so there are some people, believe it or not, there are some people doing some really crazy experiments. There's a guy, I think it's at Vanderbilt, can't remember for sure, but he's actually got federal dollars, and what he's saying is he's going to try to prove that the future's controlling the present, right? So what he's doing is he's taking a laser. So if you think, what transverse time? Well, light sometimes transverse times, because we know that the light we see from the stars took a long time to get there. And if we could actually if our naked eye could actually see what's going on in the star, we'd be looking back in time, right? So they say that a light can transverse time. So this guy's got this theory, and this is a theory. He said, well, if I take a laser and shoot it up into space, and if it never hits anything, it will go on for eternity, right? Because light will not slow down unless it hits something. So if I can shine it out into space, into complete, utter darkness, and I pull the trigger, guess what's going to happen? The future will not allow that laser to fire. So they're sitting there thinking, he's sitting there shooting a laser up into space, trying to determine whether the future is going to be all dark or not. It's a crazy experiment, but I wanted to tell you that because to me, it almost explains what do we know about light and dark, is that light always overcomes dark. It says that in the scripture. The light shines in the darkness, and the darkness has not overcome it. Now, this is talking about spiritual things, but this is true in the physical world too, right? That light always overcomes dark. So maybe the future isn't dark. Maybe the future is full of light, which we know it will be. We just got done studying 1 John chapter 1, where it says, God is light, and in him there is no darkness at all. So the unbound God is infinite. We can't comprehend that. You know, when I was a kid, when I first learned about infinity, you kind of just like, it was the ultimate answer to everything, right? I love you 100 times, and then it goes on to I love you infinity times, and then the argument's over, right? I've just pulled the wild card down and stopped everything. But infinity, as we talked about earlier, it has no practical concept in the world of time. Because if there's infinity, there's no beginning, there's no end, there's no place for time to begin, there's no place for time to end. And in our world, we cannot comprehend that. It's totally a theoretical concept, but has no practical purpose in this world. But in the God who's not bound by time, he is infinite. He is the only one that can truly be infinite. All right, so now let's talk about dimensions. And this is where we're going to go finally into the subcellular area. But God has also limited us in terms of what we can do within our physical presence. He asks Job this, right? Can you bind the chains of the Pleiades? Can you loosen Orion's belt, talking about the constellation of stars? Can you do that? Can I reach up, grab the stars, hold them in my hand and pull them down? Can you bring forth the constellations in their seasons or lead out the bear with his cubs? Do you know the laws of the heavens? Can you set up dominion over the earth? And the answer is no. God has put us into these bodies that limit our length scale, right? There's There's certain things that I just cannot do. I cannot reach out. We will never reach out to the edge of the universe, even in a spaceship, no matter what. People dream about those kind of things. They just won't happen because God has limited us in that way. So let's think about the amazing facts of the universe. All right? And as you think about these, think about what this does to your heart. Think about, as I tell you these things, what does it make you feel, or what do you think about God when I start telling you these things? So as you look out into the sky, they say there's about 3,000 stars that are visible to your eye. And if you get a small telescope, you can maybe pull out 100,000 different stars. But we estimate that in the Milky Way, which is only part of the universe, there's more stars than we can, 100 billion stars out there. There is more empty space out there than we can even fathom in our minds. The moon, which we feel is pretty close, it's still 360,000 kilometers away from the Earth. And our nearest planet, depends on the cycles, can either be Venus or Mars, but it's 42 million kilometers away. Those are distances that are hard to understand. Our sun is 150 million miles or kilometers away, and the nearest star is about 40 billion kilometers away. The vastness of the universe. I don't know if you've ever seen Lou Gigliano do the talk about, the vastness of the universe. And when you sit and think about that for a while, when you meditate on that, and you see something like this, here's the whole entire universe, and you see this one little thing, and it's pointing here to this little planet you can't even see here, and you're living in a house on that planet on a small spot, you start to feel the power and the vastness of God in your life. You can't help. As we started this conference out, I heard the song that we were singing. I think it's the verse I picked here. When I consider your heavens, the work of your fingers, the moon, the stars, which you have set in place, what is man that you are mindful of him? Human beings that you take care of them. And so in that dimension, as we walk to that dimension, we walk to this side of the cage and we peer out at the vastness of God, it brings your heart to say, woe is me. I am almost insignificant in terms of the power of God. So C.S. Lewis did this really great. The unbound God is dangerous. And what do I mean by that? He is so vast, he is so big, he is so capable of slaying all of us with one word that he's incredibly dangerous. But the beauty is that not only is he incredibly dangerous, but the unbound God is incredibly kind. And I stole this. If you watch the movie The Lion, the Witch, and the Wardrobe, the very last scene, there's Mr. Thomas standing there and Lucy, and they just had the big celebration at Cair Parvel, right? And they're all happy and everything's going. And Lucy looks off and she sees Aslan leaving. And she says, "Where's he going?" And Mr. Thomas says, "Well, you know he's a wild lion, don't you?" And she says, "Yes, I know, but he's kind." And that's the way I view that. I think that's what C.S. Lewis meant by picturing him as a wild lion. You can't tame him, but fortunately, God is the unbound God is very kind. Now, I can't help but to speak about this event. When we're talking about the great, wonderful works of God, nobody can forget. I hope nobody in this church forgets what happened here this summer on our youth event, right? For those of you who are not part of the church, we took a wilderness trip this summer. We went up to the Boundary Waters, and we were heading out on a nice journey with our boys. And we came to a spot at Basswood Falls here. This is the last picture before the event, right? We're standing there. We were portaging around these falls right here. And so there are the guys. There's one last picture we took, and then we decided that the guys could take off below these falls, head down to the end. And what happened in between was one of the canoes tipped over, right? And it went in, and poor Asher got trapped. His foot got encased in an aluminum canoe. And we spent the next 6 hours measuring our strength against the strength of that current. And guess what? We were undone by the strength of that current. This is just a small part of God's creation. But I'm telling you, we worked for 6 hours trying to get that canoe out of the water. It was so wrapped in that canoe was so wrapped around that rock that we could not move it. Yeah, the boys here know. So there I was, and the adults, we're all working in our strength, and the boys are over there praying. So in the retrospect, you guys did the more useful thing. We were working in the flesh. You guys were working in the spirit. But I distinctly remember coming to the conclusion at one point that we were outclassed. I realized that there was not a tree big enough. There was not a rope strong enough that we had. Nothing was going to pull that canoe out of the water. We were undone. In our own strength, we couldn't do it. But yet the kindness of God. Let me show you this. This to me shows you the power of, whoops, did we lose the... Let me get the connection back up, sorry. All right, there we go. All right, here's the canoe. This reminds me of the power of God. Asher's foot was stuck in that crease, and there was nothing we were going to do to get out. That canoe was nothing compared to that current. And I remember writing the next day in my devotions, I said, God, you are a lot like that river. You're wild, you're beautiful, but yet approached the wrong way, you are incredibly dangerous. And that's what happened to us in this situation. But the kindness of God is shown in the rip of that canoe. Because when it came down to it in the end, when we were pulling and pulling and pulling, and God sent us help eventually, we pulled that canoe out, and it wasn't because we're thankful for the workers, but it wasn't because we had a great plan. I can tell you that. It was quite disorganized. And as we pulled that canoe out, I can remember the canoe coming up, Asher going with the canoe going into the water, and I had no idea what the fate was going to be. No idea. But God was kind. That canoe ripped right at the right spot that his foot could come out, and we were able to pull him back out of the water. This is the kindness of God. The fact that we were able to return, with Asher, with injuries that hopefully he's totally recovered from. Yeah, he's a lot better now. Good. And that's the kindness of God. You wonder, well, God, couldn't you have spared us that whole event? Why did we have to go for all that event when it was all going to turn out okay anyhow? But God wants you to see both his power and his kindness, and we saw it in that event. So I say, God's tenderness is seen in the small things of creation. The pictures of those two babies. One of my favorite worship songs that I've been listening to a lot lately, one of the lines in it says, "Look at the way the flowers bloom for you. He wants to show you their beauty. Running waters dance, you and I," meaning you and I and God, "we romance, but unto you belongs all the glory." And that's what we see in the tenderness. Are not 2 sparrows sold for a penny? Yet not one of them will fall to the ground outside your Father's care. And even the very hairs of your head are numbered. So don't be afraid. You are worth more than many sparrows. As we move into the smallness of God, one of the pictures I tried to download was the genie from Aladdin. I love that line in that movie where the genie says, "All that cosmic power," and then he shrinks back into the bottle and says, "in an itty-bitty living space." I think God, I have no proof of this, I think God is equally infinite on the small as he is on the large. Every time we get a big hammer, we find new particles. That's what it seems to be. And so we're going to dwell into where kind of I live in a day-to-day world. And we're going to talk about DNA. So DNA is a remarkable molecule. Here are some facts about it. It's in every cell of our body except for red cells, which don't have nucleuses, apparently only in humans. I didn't realize that. Each cell has about 6 yards of DNA. So if I took this DNA out of one of your cells, stretched it out, it would stretch out to about 6 yards. Yet it's all compact and put into the center of the cell. In us, in humans, there's close to 100 trillion cells. Each one of these cells has this exact same copy of this molecule in it that really is the information code that's telling a lot of things to go on in your body. And if I unraveled all your DNA and laid it out end to end, people have estimated that said it would stretch to the earth, to the sun, 600 times. That much code in your body, just in every cell. And so if I took 25,000 strands of the DNA and put them side by side, they'd be the size of a single human hair. And yet this is the molecule that's helping you and helping me live and control the physical nature of my body. This is how it's packed, okay? So let's look at this. Let's see if I can bring up a marker here. Whoops. Nope, I guess I can't. All right, so we'll move back. So you can see on the far left, this is what it looks like. So it's two molecules spun together in what they call a double helix. So each one of those is a copy of the code. They're complementary codes. And then what happens is that those strands, then you see those little things called, I wish I had a pointer here. Maybe I do on this one. Is there a laser on this one? Yeah. Okay, here we go. These histones. So there's little balls that are made of protein and RNA, and they wrap around the DNA to kind of wrap it up into a spiral, sort of like a ball of yarn. And then those get wrapped up into another spiral, and eventually they get put into what we call these chromosomes. And there's 46 human chromosomes, 23 pairs. And the remarkable thing is that each time your cell divides, this whole structure needs to be replicated. Okay? It's amazing. Amazing that something that big, that long, that complicated, you can unravel it, duplicate it, pull it apart, and separate it perfectly to put into every cell. We just had a work day. I was talking to Pastor. We had a work day, and we were working out here, and I picked up a drag cord. And I say, every time I pick up a drag cord and spend an hour unraveling it, I am totally amazed by DNA. If you've ever sat there like, how can there be another knot? This isn't even that long. Because if DNA were the size of a piece of yarn, it'd be a mile long. If it knotted up, you would be there forever trying to pull it apart, right? But yet this DNA in our body is being replicated. Right now as we speak, your DNA is being replicated. You're not even aware of it. And it's being replicated and pulled apart from cell to cell. Amazing. So what's in this DNA? What is it really doing? Well, there is the primary thing that we all talk about is that it has the code for all the proteins. What I find remarkable about that, when they did the Human Genome Project, they were expecting to find 400,000 different genes that coded for proteins. And they only found, when they were all done, about 20,000. So the question was, well, how in the world can 20,000 genes that only code for 20,000 proteins how do you end up with 100,000 proteins in your body? And what we've learned since then is that the gene in one part of the body will make one protein. That same gene in another part of the body will make a totally different protein. And you have to ask yourself, how in the world does that gene know what organ it's in? So a gene in the liver is making one protein. That same gene in the brain is making a different protein. And you sit back and you try to fathom this, and you just come to the conclusion is, there is no way I can wrap my mind around it. But not only that, the knowledge of self is in there somewhere. Now, what do I mean by that? Well, you know how much work it is to try to transplant one organ from one person into another. It's really difficult. And to this day, it can be done, but it's always temporary. Eventually, the body always figures out, hey, that organ isn't me. And how is that done? Well, there's a set of molecules called the HLA molecules, or the human lymphocyte antigen molecules. And they do a secret handshake, basically. As cells come up, as the immune system cells come up, it's like a spy novel. These cells come up and they shake the hands with the cells, and they basically say, friend or foe, right? And so because you got that organ from somebody else, we try to match it the best we can. We try to fool the immune system into thinking, well, this is really you, because we match these human leukocyte antigens the best we can. But eventually, the body figures it out. Hey, this isn't us. Let's attack it, right? So after you get these, so some of you maybe have transplants in the audience, you're on the immune suppressant. Because of this, we try to keep your immune system curtailed down so it doesn't recognize it. But that knowledge is somewhere within the DNA. So this idea that you're very much like your mom and dad, and that's true. You get chromosomes from your mom and dad, but what we know now is that there's another pattern on top of those chromosomes called the methylation pattern, and it's a fingerprint. And even though you get a copy from your mom and your dad, before you start being formed, that code is ripped off and God gives you a different fingerprint on top. That's why I don't think cloning is really real at all. It's not going to be the same exact copy, because even when they do cloning, that methylation pattern changes. Think about it. Time is in that DNA code, right? How does your body know when it's time to go through puberty? Somehow this molecule is keeping track of time. We have no idea how that happens, but it has to be happening because we all do. There's some way to know that. The knowledge of human anatomy is in there, because when you're being formed, you start out as a single cell organism. You go to that 100 trillion cells, but everything has to happen at the right time. You need the liver at a certain time. You need the heart at a certain time. Certain things have to happen. And all that is coded into that tiny little molecule. An organ structure. Somehow you have to know that this cell, eventually, that keeps changing, says one time, okay, now I need to become a liver. I'm going to make myself different, right? And so that cell then has to differentiate itself to become a liver. And not only does it have to become a liver, but it has to tell its neighbor, okay, the liver's big enough now, let's stop. Let's not turn any more cells into liver. This is all happening without any of your knowledge. I have no idea how to explain it to you. And this is what it's doing. It's taking you from a single cell as you're being born through all the stages of becoming a human being. And at one time you start out, basically we call it a marula, like a ball of grapes, basically. That's what you look like in the very early stages, and yet look at the beauty that God creates out of that. And not only does the code do this, but it makes us all individuals. We think about that when we make things in a plant, we want to stamp them out exactly the same all the time. But God loves the diversity, and even though this code is complex enough, I couldn't imagine just trying to form a human being, but then allow for diversity on top of that. Unbelievable. This is a picture I took. This is a cell dividing. So you can imagine what this is. This is, I think it's a kidney cell from a kangaroo. But somebody figured out how to highlight some of the features in here. And so this is what we call a mitotic mitosis. That means the cell is dividing. So think about that. That tiny little molecule, 3 billion letters long, right, is replicating itself. Not only is it replicating itself, so then it's lining up as the nucleus dissolves and these spindle-like organisms come out. They grab the chromosomes, they attach themselves properly, right? And they have to pull themselves apart, and that's what's happening here. That these spindle apparatuses are pulling the chromosomes, one copy to each cell. You can see them migrating until finally the cell divides, and so now they each have a copy of the DNA, and then they get sucked back into the nucleus, and the nucleus reforms. An amazing event. It's amazing to do once, but to start as a single cell and do this 100 trillion times with fidelity. Where's Mr. Perry? Is he in here? It goes beyond 6 sigma. He's not here. I don't see him. He's a statistician. It goes way beyond 6 sigma that we talk about in manufacturing. It's unbelievable. But what's the cost of mistakes? We got a 3 billion letter code. What is the cost of a mistake? So I'm a pathologist. This is the area that I lived in and I've been trained in. And what this is a picture of your colon, right? So this is the muscle layers. There's a couple muscle layers here. There's a longitudinal and then a circular muscle layer that helps you both to squeeze and to elongate your colon. And we call this a submucosal layer. And then we have the mucosa where there are plenty glands here. And what those are doing is taking in water, making sure everything is done right so you get proper nutrition and proper water balance, and so everything is organized. But yet we all know that it can go unorganized. And this is sort of a picture of what it looks like. Whoops, sorry. You can see what this is colon cancer, what it looks like under the microscope. You can see what the cancer does. So mistakes in the genetic code trigger cancer, and you can see what happens. All chaos breaks out, as we call it. We call these cells, we used to say these cells look angry. And I know that that's hard for you to do, but for us pathologists, they say they look angry because they're not well behaved like the cells up here. And so the cost of the mistake is the cancer that we deal with. So I just got back from Rome. I was at the International Myeloma meeting. And one of the big news, right, of the International Myeloma was this finding here. And I'll tell you about it. So there's a disease called Waldenstrom's macroglobulinemia. It's sort of a rare disease. And what happens is that these B cells, which are circulating in your body, they're part of your white blood cell system, they can go malignant. They turn cancerous, meaning they're uncontrolled in their proliferation. So they keep on multiplying. And these are the pictures of the cells that are malignant, and this is the nucleus of the cell, this is the cytoplasm of the cell. And so they've been searching for the reason why these cells go malignant. And this is kind of a fascinating one to me, because normally there's lots of changes that happen in the DNA that force cells to go malignant. But people now realize that there's one protein here, and this is the title of the talk that was given. It says, "A New Era for Waldenstrom's Macroglobulinemia, MYD88L265P." And what this means in pathology terms is this is the name of the protein. It's called MYD88. And there's one single change in that protein from a leucine going to the proline in this position 265 is what's causing the cancer. So here we have a 3 billion letter code. Basically three letters get mixed up and you have cancer. It's kind of frightening. Like I think about that, but nobody in that meeting, like I was sitting there going, wow, a 3 billion letter code, one mistake, and can lead to something that totally takes your life, right? And the way it does it is that every cell, so this is supposed to be the cell wall, so this is supposed to be the outside of this cell. Every cell wall has antennas all over it. They're all constantly searching for signals from other cells in the body to tell them what to do. And this just happens to be one of the cell signaling mechanisms that we know about. So some sort of molecule comes in here, stimulates this. I'll call them antenna to put them into regular terms. The antenna pick up a signal, and then it gets amplified through the electronics like a radio, and then action's made in the cell. There is part of this antenna is this MYD88 protein. And so this one amino acid change in this protein changes this to constantly turn the signal on. It's thinking it's getting signal all the time. It's getting a signal to grow. And so what happens then is this cell then goes on and becomes malignant, and this process can end up taking your life. But I didn't hear anybody stand up and say, well, that's not fair. There's 3 billion code. I make one mistake and it takes my life? What about the millions and millions and millions of times this cell did it right? Why can't it get a break, right? And I kept thinking about this, that if I stood up and said the same thing spiritually, really, one mistake out of all the things you do in life, one sin can actually lead to a process that takes my life. Very true. Therefore, just as sin entered the world through one man, and death through sin, and in this way, death came to all people because all have sinned. Adam picked up that defect when he sinned. And just as those cancer cells, they started proliferating, they passed that defect on to every other cancer cell. And that process ends up taking your life. But the same thing's true spiritually. Adam had a defect. He sinned. He passed that on. And that one little sin ends up taking our life. All right, we're going to talk about the amazing nervous system, and I'm going to speed it up because we're running out of time a little bit. This is another system that's totally amazing. What I'm showing you here, this is a neuron. So this is one of the cells that's involved in your brain, in your thinking process, in your motor process, right? The thing I find amazing is I'm using my neurons right now to tell you about neurons, right? That's kind of an interesting thing. But how did this central nervous system come into being? Well, at one time in your life, you were basically just a flat disc. And on this flat disc are the layers that are going to form you. Here we have the ectoderm and the endoderm and then the mesoderm in between. And it's somewhere along the line, those cells that all started out the same, some of them decide, okay, we're going to become the nervous system. And so we call this thing the neural plate. All right, and so what happens then is this ectoderm folds into this structure here, and this becomes the neural tube, which is then going to become your spinal column, basically, and the nerves coming down through the spinal column. And then you're going to have this notochord, which becomes your vertebrae that goes around these. So eventually it's going to surround this. And if you get defects in this closing, you've heard of spina bifida, babies being born with spina bifida. If this doesn't close properly, that's what happens. But there's an amazing set of cells that come out of this when you're born. These are called the neural crest cells. And I find them very interesting because basically they're surrounding the notochord and they decide through some signaling mechanisms, we have no idea, we're going to take off and we're going to head out through the body. So a group of cells pick up and they basically leave home and they start migrating through the body and they become different things, all right? One of them they become are melanocytes, right? So this kind of explains why melanoma is so deadly, right? When you get a melanoma, these cells are programmed to move. And by the time we find melanoma, they've already migrated through the body because they're migrating cells. But another set of cells I want to talk about are these cells that go off and become other basically nervous cells within the body. And one of those are the ones that go to your gut, to your intestine, okay? And I want to talk about those just a little bit. This is a mouse embryo, and somebody figured out how to highlight those neural crest cells. So here they are. They were once all aligned along the spine, and boom, they take off, and they're running all through your body. They know where they're heading. It's amazing. They know where they're heading. I don't know how they know where they're heading, but they know where they're heading. And here's a set here that ends up in the gut. This is what we call the Meissner's plexus. So in your gut, just like your heart, you have a pacing system. That's what's controlling your digestion. Just like your heart rate, there's a set of pacers. And here they are lining the mucosa here, and they're innervating the motility of your intestine, okay? If they don't migrate right, you could have heard of maybe Hirschsprung's disease. Maybe you had a baby with Hirschsprung's disease. They don't go all the way, and so you find a piece of dead bowel that's not innervated. But these neural crest cells then started one time right next to the spinal column, and they migrated to the gut. Okay? But then what has to happen is they have to get innervated. And this floored me when I saw this and I learned this. So then what happens is after these cells take off, one of the neurons in your brain says, okay, I'm supposed to take care of the gut. And this sends out an arm, an axon. So this arm comes out of the central nervous system and can trace where that neural cell went. So it's following its neural crest bunch. And it's migrating through the body until it gets close to the gut and then, boom, innervates the gut. I find that just amazing that can happen. It's not the way I would have designed it, but that's the way it happens, and I'm just floored by that. So you have some cells that live in your neural system with axons that extend all the way from here, all the way to your gut. So how in the world, all the nutrients and all the things are made by the nucleus and the mitochondria, how does it keep the cell alive? And so what people have found was, if you look at this, if it comes up, that there's actually a transport mechanism for these cells. So this is the nucleus. This can be as long as going all the way from your spinal column all the way to your intestine. So there's this big long arm. And what we found is that there's There's basically a railroad system working in these cells. There's these tubes that run down all along the way with little cars. These are the cars, and they're programmed. These ones are the ones that head in one direction. There's another set that head back up, and they're carrying nutrients that are made here all the way down to the end of the cell, including even the vesicles that have to be released to innervate it. They're all made here, and they're transported back and forth, all under some command. We have no idea how that happens. One more, and then we'll move on. The Purkinje cell. This is another one I find really fascinating. This is a picture of the cerebellum. So your cerebellum's in the back of your brain, and it's the organ responsible for balance. Okay? So it has a very complex job. It's got to be reading all the signals from your muscles, from the balance organs in your ear. Your sight is giving some stimulation into your balance. So there's many things that go into balance, right? And so these Purkinje cells are the integrator of all these signals. And when you look at them, they lie here between what we call the granular layer and the cerebellar layer. And if you could look at them, you can't quite see it here, but if you can highlight them, they have these very, very complex tree-like structures coming out of them. And what they're doing is they're sitting there sensing signals from all the other cells around. The idea of neural networks sort of comes from this kind of thing. And they're making very complex decisions for your balance based on all these signals. And to us, it just looks like a random kind of thing, but it's not random. It's well programmed in order to control your balance. But the amazing thing, even more amazing thing to me, is that I can go in, and I won't because I'm not a surgeon, but a surgeon can go in and take out half your cerebellum, and you will not be able to walk for a while. But with training, these cells can relearn how to control balance, even though half of them are gone. What kind of man-made machine can you do that to? Take out half of the machine and have it still work. Just amazing. So when you look at this, and the Bible tells you, cast all your cares on him because he cares for you. He cares for you. He made this system. You don't even have to think about it. It's slaving away for you right now. You know, those cells, I always think about the cells, the analogy of the body. If those cells were to rebel, what would happen, right? But they don't. If the cell says, wow, I got the signal, but I'm not moving now, we'd all be in trouble, right? But we as humans, we kind of act that way. But cast your cares on him because he cares for you. So tomorrow we're going to finish this cage. So what I hope you saw today is that in this cage, in the small, the dimension of small, you kind of saw what I would say God's loving care for you. And in the big, what did we see? We saw God's power, right? God's power we saw in the big. Yet there's this time thing. In the future, our heart longs for eternity. And in the past, we see life lessons, right? But there's a greater revelation in the center of the box. And tomorrow we're going to focus on the center of the box. And on the future, in the big, we saw God's power. In the small, we saw his loving kindness. But if that had been enough to bring us to repentance, there would have been enough to be said. But there's a greater revelation in the center of the box. What's the center of the box? It's the present and the human length scale. And tomorrow we're going to talk about that greater revelation. So if you don't know what I'm talking about, a lot of you go, I know where he's going with that greater revelation. But if you don't know, come back and listen, because it is probably the more important message. And if that doesn't bring you back, the subtitle of tomorrow's the message I'm going to give is, you can't hunt elephants with a BB gun. All right? So if that doesn't entice you to come back, I don't know what will. So, all right, let's pray. Well, Father, we're just thankful to come before your presence, and Father, to worship you, because you are indeed worthy of all worship that we can give to you. I thank you for the messages that I heard today, Father, that what a great friend you are. You don't lie to us. Although the world may lie, you don't lie. And what a great friend you are, and what a kind and powerful God you are. And Father, we desire to give you glory. In Jesus' name, amen.